Morning, Miss Gilbert. Good? Good? Hold, please. Hello and welcome, and we are Arrowhead. Before I start this presentation, let me ask you guys a simple but fairly question. Does anyone think it's possible to catch a speeding arrow? Show of hands, please. One? Oh, got one? Maybe two? Okay, so it's either you guys are asleep or you guys don't believe that it's possible to catch a speeding arrow. Well, you guys are right and wrong. Here's why. Did you know that an arrow, a speeding arrow, can go up to 85 miles per hour, according to the length of the arrow, which could range from 5 to 15 seconds.
And the normal reaction time of a human being is 0.2 to 0.3 seconds.
However, ninja's reaction time can be up to 0.1 seconds.
So now let us give you a scenario. I, the archer, will be standing 25 feet away from our ninja and firing non-lethal arrows at a ninja in hopes that he can catch it.
Oh!
Oh, so close.
So unfortunately, there's many factors that need to be taken into account when firing a bow and arrow. So again, a ninja's not always guaranteed to catch an arrow.
Some of these factors include wind, force of the bow pull, and or just maybe our ninja needs more practicing. But anyways, there is calculus behind the speed of the arrow, which is when it flew towards the ninja. So how do we do that? Well, let's check it out. So start off with application of physics using a force diagram of force of air and mass of gravity. However, force of air is the only factor that we can take into consideration since it is the horizontal direction. So the force equation that we find is F of D equals 1/2 times rho of air times Vx squared times coefficient of drag times the surface area, which essentially speaking is how much force is applied by the wind when the arrow is flying toward the ninja, which would then equal mass of the arrow times acceleration x, based off of the fact that the force equals force of the drag. So then we multiply by 2, divide by rho air, and see coefficient of drag and surface area to get Vx squared equals 2 times the mass of the arrow times rho of air times coefficient of drag times the surface area. Now, I'm not going to try to tell you guys to solve all those numbers because those are really arbitrary. So those are the numbers that we will be using today. We solve those on our own time. And then we take all those numbers and we plug it into the equation on the next page and multiply it by acceleration in the horizontal direction. Which we then also, in calculus, we know that the acceleration of x is dv over dt, which is the derivative of velocity. So then we plug that into the equation to get Vx squared equals 193.84852 times dv dt. Then by using calculus, we integrate both sides to get 1/3 v of cubed, which then equals this arbitrary number times t, which we know is 2 seconds. So then we multiply that by 2, multiply by 3 from the 1/3, and then cube root it to get about 20 meters per second, which is relatively fast for a human being to catch something that's flying at them, or even a ninja. Then again, as I said, you might just need more practice.
So as you can see, calculus can be applied to any scenario, such as the one with the bow and arrow, to determine whether a ninja can catch an arrow or not. So now, would anyone like to volunteer to shoot an arrow?
You could try to catch it? No, it's only shoot.
Right.
Only shoot. Oh, Miss Gilbert. Give Miss Gilbert a round of applause. Yes, you can have a chance to win an Arrowhead water bottle plus a Snickers if you hit the whiteboard. Ooh, pull back a little bit. Oh, give her a hand. All right. Anyone else before we head on off? Want to try it? All right, give her a hand. Okay. Pull back. You can try to pull it back as, con ganas. Oh, it's okay. Give her a hand. Alright, thank you all for coming. If you guys like what you saw, you guys can give us a vote. And you guys can start heading up to the hustle event.
Thank you.